we're going to continue on with our second lesson on RF6 and 7, linear relations. So this next form we're going to look at, we looked at slope-intercept form last time that told us, based on the title, the slope and the y-intercept. This time we're going to look at point-slope form. What point-slope form is going to do for us is it's going to tell us two things. It's going to tell us the slope, right? Hence the slope part of the name. And it's also going to tell us one point that's on the line, right? Hence the name, point-slope form. Our equation looks a little bit different this time. We have y minus y1 equals m times x minus x1, which looks a little bit weird. All right, so we have y's, we have a y1. Really, this is just a reconfiguration. We've just changed up the original slope formula. If we recall, we had m equals, right, change in y over change in x. Right, that was our slope formula for talking about the rise over the run. All I've done here is I multiplied. I wanted to get rid of this denominator, so I multiplied both sides by that whole x times, or x minus x1, and now it's been multiplied by m, right? What this ends up leaving us with is this expression where we have m for our slope, right, which we called m our slope before, and the x1 and the y1 are telling us the x and y coordinates of a point on this line, right? The plane x and the plane y are just that same x and y we see in any equation. So something like this, we can be given a slope of 3, and we can given a point, right? That was one of our options when we had slope-intercept form, but we had to do some extra work in that form. Here, these two pieces of information are all that we need to create our equation in point-slope form. So we have an m value of 3 from that slope. Again, reminder, we're always looking at coordinates in the form x, y. We write the x value first, the y value second. If I'm then plugging this into my point-slope form, right, I'm taking it piece by piece, I have y minus y1. And we said that y1 had a value of 4, right? It was the y coordinate in that ordered pair. And then on the right side, I have m, right? And we said that m, our slope, was 3. And then we had an x1, and that was the x coordinate in our point. That's what we said was 5. So while this looks a little weird, it doesn't quite look the same as slope-intercept form, this is also an equation. And again, it tells us a few different pieces of information. It tells us a point rather than a y-intercept. Here we want to be careful of negatives, because if we notice, these subtraction signs are part of the equation. Right? Last time it was mx plus b, so we knew that if we were just adding a negative, we'd subtract. Here, if we're dealing with negatives, things look a little bit different. So this time we have a slope of 2, so it's going to tell us our m. And then we have a point where both our x and our y coordinates are negative. So we're going to have to be extra careful about what we put in for x and y. Right, m is that slope of positive 2. Our x coordinate was negative 2. Our y coordinate was negative 1. Now when we plug that into our slope point form, I want to make sure I'm keeping the sign and also keeping that subtraction that was part of the equation. I'm subtracting a negative 1 for y1. My m is the same, but I'm subtracting a negative 2 from x. So when I rewrite that, I want to be extra careful, right? Remember when we subtract a negative, that's a double negative. I'm going to see that as a y plus 1. And then when I'm subtracting a negative 2 from x, I'm going to see that as an x plus 2. We want to make sure we fully simplify, get rid of any weird double signs that we see. Point-slope form. Given these pieces of information, we can write that equation. Right, again, all we need is two pieces of information. This time we need to say what is the slope, And what's a point that we have? We just want to make sure, again, we're plugging things into all the right spots. We're always going with y minus y1 equals m times x minus x1. And this is on your formula sheet as well. So I go ahead. I know I have a y. I leave that as y, right? I need a place to put in any other points on the graph I might have. And I subtract my y1 value, right? Making sure I'm taking the y coordinate and not the x just yet. Equals m, which had a value of 4, times x. Again, we leave this x blank. That's the x that we can input any other x that shows up on the graph. Minus 2, right? Remember that subtraction is built in. I'm always subtracting, right? And because I had a positive 2, I'm subtracting that positive 2. Trying the next one. Y minus, and this time I notice my y coordinate is a negative 2, equals negative 1 for m, x minus, and I had a positive x value, so I have x minus 9. Again, I want to simplify this. I want to write it as cleanly, as simply as possible. So that's going to end up looking like a y plus 2 on the left side. And a negative, again, because it's a coefficient. It's a coefficient of that binomial bracket. I don't need to write the value because I know it's a 1. So it's just a negative x minus 9. Take a minute, pause, try C and D, and then come back. So we're going to get a y minus 4 equals 7/4 times x plus 3, again, because of that double negative there. Let me fix that plus. It's looking a little funny. And then for D, I'm going to get a y plus 5 equals negative 3/2 x plus 7 because of both of those double negatives there. We can also look at graphs. So same thing we did with slope-intercept form, we can also look at graphs and come up with their equation in point-slope form. This time, instead of finding the slope and the y-intercept, I'm going to find the slope, and then I can just pick any point that lies along this line, any point that happens to be a nice point. So for the slope, again, what I'm going to do is I'm going to pick a couple of points, any 2 points that I want on the graph. So let's say this one and this one. Right, and I'm going to say, how do I get from one point to the next? What's my rise? Well, I have a rise of 2. What's my run? Well, I have a run of 2. So overall, my slope is 2/2, which I can say this thing has a slope of +1. Then, when it comes down to talking about the x1 and y1, I'm just picking any point on this graph. It doesn't need to be an intercept, it doesn't need to be a specific point. Any place where it nicely hits a nice ordered pair, we're okay with. So I chose this one. Again, you could choose any of them. And I see that that's at 3, -2. So that tells me I'm going to have an x value of 3 and a y value of -2. Now when I go to write my equation, again, same form, y minus y1 equals m times x minus x1. It's going to look like y plus 2, again, because of that double negative, equals m, oh, my equal sign looks like a frowny face, equals my m, which was just a +1. We could write that, we don't have to, times x minus 3, because my x was a +3. And here with point slope form, things might look different. You could have chosen any other point on the line, right? Because point slope form just cares about one point that's not any specific point, your solution can look different, but they're talking about the same line. So let's try the next one. I'm going to do the same thing. I'm going to say, what's my slope? So again, between any 2 points, okay, here I see that I have a rise of -2 for every run of +1. So I get a slope of -2. And then I'm going to pick a point. Again, I can pick any point. I could pick an x-intercept or a y-intercept if I wanted. I'm going to choose this point, -1, 4. So I have an x value of -1. I have a y value of +4. So my equation then looks like y minus 4 equals -2, that m value, times x plus 1 because of that double negative. Take a minute and pause, give the bottom 2 a try, and then come back. All right, so working through the third one on the bottom, finding our slope, it looks like we have a rise of 2 for every run of 1. So we have a slope of +2 this time. And I'm going to pick, let's try my y-intercept for now, make it look like slope-intercept form. That has an x value of 0 and a y value of +4. So we get a y minus 4 equals 2 times x plus 0, or sorry, x minus 0. Either way, it does not change anything. It also looks like I have a little dot there. There we go. And so really, this is just point or slope-intercept form in disguise. And we'll see how we can kind of convert from one to the other in a minute. Looking at the fourth one, I see that I have a slope of -2. I can pick any point. Let's try this one at -3, +2. I'm going to get a y minus 2 equals -2 times x plus 3. So let's find the slope if we're given 2 separate points. Right? We have 5 spaces to put numbers. We have 5 variables. We have a y and a y1. We have an x and an x1. And we have an m. Right? And again, we know that we can solve any equation as long as we can fill in every blank except for one. So in this case, we're going to be given 2 points. Right? We have point A. We have point B. And so that's going to tell us 2 different y's, right? Y and y1. It's going to tell us 2 different x's, right? X and x1. And that way the only thing we have left to find is m, to find our slope. So I'm going to go through my x for my first point, 6. My y was 4. My my x for my point B, my first point was 2. My y was -4. All right, I'm just pulling the x's and the y's out of each coordinate. So it doesn't actually matter which one we use for which, right? I could flip this up and we'll look at that in a second. But I'm going to plug in these numbers. I'm going to plug in my y value. And then I'm subtracting my y1. So I'm taking, right, this 4 that I had here. It's going to go down here. And then I'm subtracting this -4 that I had here, right? That's my y1 value. And then I'm going to go ahead and do the same thing with my x's. I'm leaving the m there because that's my unknown. That's what I'm trying to find. So again, I put my x value first, 6, and I subtract a +2. Right? My x value from my point B was a +2. And the only thing we want to make sure of is that our y's are in the right spots and our x's are in the right spots. We don't want to flip those 2 things up. So I'll do a bit of the math. I'm doing 4 minus -4. What does that look like? Well, we know that that's actually really just a 4 plus 4. So I get an 8 as my only value on the left-hand side. And then when I'm doing that math inside the brackets there, I have a 6 minus 2. I get a positive 4 inside the brackets there. To solve for m, right, I want to get it by itself. Right now it's being multiplied by 4. We're going to divide both sides by 4 to break that bond, right, to keep m by itself. And so that's going to end up telling me that m, my slope, is positive 2. So when I go to write the equation, I'm going to go back to, again, leaving the y and the x blank, right? So that I'm talking generally. I'm not just talking about one specific point. I'm talking about the line, which is the group of like infinite points. So I'm going to do y, and then I'm going to do plus 4 again, because I was subtracting that -4. I'm going to replace m with the value I know, that it's 2. And then in the brackets, I'm going to do x minus 2 again. I'm going back to calling x, but I can leave that x1 value in there, that 2 from our point B. If we tried to do it backwards, if we flipped it around, right? Say I called point B my x and my y, and I called point A my x1 and my y1. Well, let's do it quickly. Right? Let's say we had -4 minus 4 equals m, 2 minus 6. Right? I'm doing y minus y1. So I did -4 times, or sorry, subtract 4. And I'm doing x minus x1. So I'm putting the 2 first and then subtracting the 6. So on the left-hand side, it'll look a little different. We'll have a -8 equals m times -4. Well, when I divide both sides by -4, it's going to tell me that m is still positive 2. So we have the same slope. And I can write it a little different as well. If I decide to write it as y plus 4, oh, sorry, looking at my poor writing, y minus 4 equals 2 for m, x minus 6, right? My equations look different. If I look at my 2 results, this is supposedly talking about a line, and this is supposedly talking about the same line. So how can we know if they're the same? Well, because point slope form can talk about any point, it's not the most reliable for comparing equations, seeing if they're the same or not. What is good for comparing equations is slope-intercept form, because the slope has to be constant and the y-intercept is the same regardless of how we decide to express the equation. So we want to convert to slope-intercept form if we want to make sure that things look the same. So looking at the 2 equations we had last time, right, this was our second case. We had a y minus 4 equals 2x minus 6. Let's convert it to slope-intercept form. And remember, slope-intercept form had that y isolated. It looked like y equals mx plus b. There was no brackets, and y was all by itself. So to make our point slope form look a little bit more like that, first thing I'm just going to distribute into those brackets. So I'm going to do 2 times x and get a 2x. And then I'm also going to do a 2 times that -6, right? Making sure we're following those distribution rules that we know. Then I want to bring that 4 to the other side, right? I want to get y isolated. So I'm going to add 4 to both sides. That leaves me with y equals 2x minus 8. Right? Still shows me that slope, but this is also telling me Right, it's telling me slope is 2, which we knew. Oops. There's no end to the smartboard mistakes, even from home. Slope is 2. My y-intercept is at -8. Let's try the next form, right? This one looked a little bit different. Y minus -4 is 2 times x minus 2. That was the first equation we saw. And we're going to do the same thing. I'm going to distribute into those brackets. And again, because I was subtracting that negative, I'm technically multiplying into that bracket to turn it into a plus. So I get my y plus 4, and I get my 2x minus 4. Again, I'm doing the 2 times the x and the 2 times the -2. This time, to get that y by itself, I'm going to subtract 4 from both sides. But what I see is that I end up with the exact same equation. I have a slope of 2, and I have a y-intercept of -8. So that tells us these have to be the same line. There's no way that two numbers can have the same, or sorry, two equations can have the same slope and the same y-intercept but look different. So let's try these next two. Let's convert from, these are given in slope-intercept form, and we want to convert them into, or sorry, these are given in point-slope form, and we want to convert into slope-intercept form. All right, so we're going to do the same thing. We're going to make sure we're distributing properly. Right, a couple of key tips here. Back to that AN4, how do I multiply a monomial by a binomial? And then I want to make sure I'm getting y by itself so that it looks like that slope-intercept form we're used to. So first things first, I'm going to distribute out, right? I don't want those brackets. My slope-intercept form doesn't have any multiplication by binomials. So nothing changes to my left side. But now I have a 4x minus 8. Then I want to bring that minus 8 over. I'm going to do the opposite to get rid of it. So I'm adding 8 to both sides. My goal leaves me with just a y on the left side. Right? That's what I wanted. On the right side, I had a -8. I gained 8. I'm actually at a nice total of 0. So I can write that as a 4x plus 0, or, oops, I can write that. That's just a y equals 4x. And so again, we look at this and we're saying, what does this tell us? Well, we have a slope of 4, which we do from slope point form. And we have a y-intercept of 0. That means we hit the y-axis right at the origin. Right? It doesn't mean we don't have a y-intercept. It just means that it's at a value of 0. So slope is 4. The y-intercept is just the coordinate 0, 0. All right, remember, a 0 doesn't mean it doesn't exist. It just means it has a value of 0. So let's try the next one. I'm going to simplify some of these double negatives first. Right? Following BEDMAS, brackets inside brackets happen first. Right? That double negative gives me a plus 8 on the left side. That double negative gives me an x plus 3 on the right side. Now I can bring that 2 in, right? Making sure when we follow our correct order of operations, the B means do those brackets inside first, right? Anything inside brackets, let's deal with that. Then we can deal with some multiplication. Then we'll deal with addition and subtraction. Oops, so I have a y plus 8. I'm not going to worry about the left side just yet. There's not a lot going on. But I'm going to turn the right side into a 2x plus 6, right? 2 times x and 2 times 3. Now I'm going to get that y by itself. I have something that looks like y equals 2x minus 2. So again, asking ourselves, what does this tell us? Well, it tells us we have a slope of 2, right? We're increasing positively at a rate of a rise of 2 for every run of 1. And I have a y-intercept at the point 0, -2. So pause, give the bottom 2 a try, and then come back. For the third one, y minus 4 is 3x plus 6. When I bring that 4 to the other side, I get a 3x plus 10. And for the last one, y plus 3, I get a 6x minus 42 on the right side. When I bring that 3 across, I get a 6x minus 45. And for each of these, it also wanted us to identify the point that was given, right? What was one point that was on this line? And so starting from the top, we had an x value of positive 2, right? That's coming from that idea that we have our x value here, our x1, y1, comes from our x and our y. But remember, we want to make sure we're where the sign doesn't follow quite the same, right? It is x minus x1. So we actually have a positive 2 for x, because I'm subtracting, like the equation told me to, a positive 2. And I have a positive 8 for y. For my second equation, I had an x value of -3, right? We can see that we were subtracting a -3, and a y value of -8. For number 4, they've done the work for us. They already changed it to that positive 2, so we want to be extra careful. This is an x value of -2, right? This is the same as x minus -2. And then we have a positive 4. In this last one, positive 7, because that negative's there. So we're going to get a -3, right? This is y minus -3. We want to make sure we're pulling those numbers from what we know the expression actually looks like, right? We're still following that idea that we have y minus y1 is m times x minus x1. So if it doesn't look exactly like that, we want to be worried about changing those signs. The last thing we're going to look at is graphing point slope form. So we've used a graph to find the equation. We can also graph our graph given the equation. So we're going to pull out, again, those pieces of information that point slope form tells us, which is the slope and a point. We're going to start similar to last time. We're going to start by plotting the point. We don't have a y-intercept like we did for slope-intercept, but we have any point. And then we're going to plot a few points to the right and a few points to the left. And this says y-intercept, and I'm realizing that means we want 2 points to the right of the point, right? The point we're given, x1, y1. So let's give this one a try. First, we'll pull out that information. All right, we have a y value of 4, so, sorry, we have an m value of 4. So our slope is 4. And then for our point, we're pulling out that x value and that y value, again, keeping in mind the signs. It's going to look like a positive 2 for x and a positive 3 for y. So I'm going to plot that point first. I'm going to find the point 2, 3, make a nice point. Now I'm going to use that idea that my slope is 4, my rise is 4 for every run of 1, because I don't have a fraction here. So I'm going to go rise of 4, 1, 2, running out of space, 3, 4. So that next point will go quite off the graph. We can work backwards as well. 1, 2, 3, 4. And then 1 point left to counteract the fact that we went down. 1, 2, 3, 4. And then 1 point left. So we'll connect that with a nice straight edge. Draw an arrow to say this is going to go on forever. And we're done. Let's try the next one. We have an m value of 2, right? A slope of positive 2, a rise of 2 for every run of 1. And here our x and y values are negative again. So I'm going to get a -3 for x and -2 for y. Right? Remember, we're looking at what is the value after the subtraction sign. So I'll start by plotting that point at -3, -2. Again, find your x's first, then your y's. Where do they meet? Now I have a slope of positive 2. So I'm going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And I'll do one backwards where I rise negative. But to offset that, I run in the backwards direction. And so here is this line. Connect it with a straight edge. Add your arrows. Pause. Give the next two a try. So we have the y value of 3. Here we have an x value of -2, right? Again, being extra careful with that positive sign. We're asking ourselves what number follows the subtraction. And if there is no subtraction, we kind of want to say, well, what would have happened to create that plus sign, right? Well, that would be subtracting a negative. So I'm going to plot this point at -2, 4. I have a slope of positive 3. I don't really have much space to go forward, so I'm going to go backwards. I'm going to rise downwards 3 and run backwards. Rise downwards 3 and then backwards. Uh-oh. There we go. No. There we go. And last one, I have a slope of 6. I have a point of 1, -3. So when I graph that one, I'm going to find that point first, 1, -3. And the slope of 6 means I'm going to rise 6, 4, 5, 6, and run 1. I don't have a whole lot more space, so I'm just going to connect my line now. I did a poor job of that. There we go. And it's a little hard with only 2 points to really know what exactly this might look like, but this is probably our best bet. Right? It's going to be a really steep line. A slope of 6 is saying that we grow vertically 6 times faster than we grow horizontally. It's going to be really steep. All right, so that's where we're going to leave this off. The next lesson is going to be on general form. That's the last form we'll look at. So for now, make sure you subscribe to this YouTube channel. Make sure you're trying some of the practice that you see online, checking out that D12, popping into the virtual lessons if you have any questions on this. And I will see you guys in the next lesson.